All right, so we've spent a couple of days on implicit differentiation, so now we're going to do it with the second derivative, which means you take the derivative and then you do the derivative of the derivative. The derivative of dy dx is this right here. Yes, but yeah, no. Hang on with notation. Back it up. Do not get ahead of me. Okay, so I want to make sure that you understand, because notation is important. Want to make sure that you understand what's happening when we take the derivative of this. Like anytime I'm going to take the derivative of anything, if I say, okay, I want to take the derivative with respect to x of something, right? So that something in this case is y squared plus xy equals 25, okay? So what I just did in blue, a lot of times we just leave that off at the beginning and then we just start taking the derivative, but this is what we're doing. So we're basically, this means we're taking the derivative. So you basically distribute this to each little term, right? So when we take the derivative of y squared, we get 2y, and that's dy dx, because I took the derivative of something with an x with a y in it, right? Plus, and then I have to take the derivative of this. What am I going to have to use? Product rule. So it's the derivative of the first, which is 1. You can choose to write it or not. 1 times y plus the first, which is x, times the derivative of y, which is dy dx. And that's equal to what? 0, because the derivative of 25 is 0. Everybody with me? Okay, so now I check back up here. I have 2 terms with y in it. I have 2 dy dx. So I'm going to leave those over here. 2y dy dx plus x dy dx equals negative y. Then I'm going to factor out that dy dx. That leaves me with 2y plus x equals negative y. Right? And then I can divide, so dy dx is equal to negative y over 2y plus x. Okay? Everybody with me on that? Any questions on how we got there? Okay, so now to take the second derivative, I'm going to take the derivative of this. So we're going to say, we're going to take the derivative with respect to x of dy dx. Here, let me choose that color. So I did that it's in pink over here. So dy dx equals negative y over 2y plus x. Okay. So I'm taking the derivative of the derivative. That's how you get the second derivative, right? So dx of dy dx is going to be d squared y over dx squared. And it's very important that you get the little 2's in the right place. Okay? Otherwise you're saying something wrong and, that could be bad for you. So that equals. Now over here, what am I going to have to use? Quotient rule. Okay? So I'm going to take the derivative of the first one, which is going to be negative dy dx times the second, which is 2y plus x, minus the first, which is a negative y, times the derivative of the second, which is 2 dy dx plus what? 1. And notice my signs here. It's minus, and then that's a negative y. This is being multiplied, and this is being multiplied. If this was more than one term, I'd have to make sure I have parentheses there, right? What goes in the denominator? Good. 2y plus x squared. Okay. So, I can't leave it like that. I have something I can substitute in there, right? I have this dy dx right here. That's what this is. That's what I substitute in here and here. Okay, does that make sense? So I'm going to substitute in, and it's not going to look real pretty at first, and that's okay. So we're going to have d squared y over dx squared equals, all right. So I'm going to have negative dy dx. Well, this is a negative y, so if I just put this in as positive, then I'll be fine. So I'm going to put in y over 2y plus x times 2y plus x, and then I'm going to multiply these, but this negative times a negative is really just positive, right? So positive y times 2 times negative y over 2y plus x plus 1. Oh, wait, hang on. I'm sorry, I don't need that parentheses there. I have too many parentheses. Well, if we already opened that one, we can just close it right there. I didn't need to do that. Oh my gosh, I put another plus there. Because I'm not multiplying 2 by everything. I'm only multiplying 2 times this part. Just plug in the dy dx, right? And then the denominator is 2y plus x squared. Now, there's a lot of cleaning up we can do. We're not going to, okay? Because if you do have something like this, there would be an application following it. It would most likely be on a free response, and things would kind of work out nicely. So there's really no reason to try and do any crazy stuff here. Okay, so I didn't because this is negative, and that's why I did that. So I could have put negative and then negative up here. I just went ahead and took care of it, but thank you. This is a safe stop, yeah. And we are going to just stop there. Because that could go, I mean, do you see some things that could happen, though? Like, I could cancel these out, right? And then I just have a y there. I mean, and so it will clean up some, but again, we're not worried about the algebra behind it. Okay? We're all good so far? All right, so then I want you to try this one. And do this notation I have in blue, because I want you to get used to seeing that and knowing what to do. Okay? How do I what? So yeah, so you just put, I'm going to take, so what this means is I'm going to take the derivative with respect to x of, and then x squared minus xy equals y, like so. Then you take your derivative. When you get your first derivative, let me check it before you move on, just so we're not moving on with bad stuff. Mm-hmm. Yep. Wait, what do you have it set? Show it. I have it written 2 different ways, and actually I feel like something is wrong. No, it's right. What did I do? I'm not so sure about this now. No, because this negative, you have to distribute. Yeah. Okay. So I do have the right thing written down. Well, this shouldn't be negative here because you didn't do this part right. What? Back it up. Something is totally backwards here. Okay. So we're getting, hang on, let's back up. We're all doing the same wrong thing, which is bad, bad, bad here. Okay. I take the derivative of x squared, that becomes 2x, right? Minus, what do I have to use here? Product rule. How many terms do I get with product rule? 2. So I have to have parentheses here. The derivative of x times y is just y. plus x times the derivative of y equals dy dx. Right? Oh, I forgot to close my parentheses. That's fine. That's fine if you do it that way too. But you know, it kind of depends on where it is in the problem, what makes more sense. So what I have is 2x minus y minus x dy dx equals dy dx. Then go forth and find it. Yes. 2x minus y. Yep, good job. So go on and find the second one. And you had your numerator and denominator flipped. Okay, got that. Well, where did x? Well, what happens with this term? If you divide this by dy dx, what do you get? It's really 1 plus x. No, you had a minus. You had something else. You had a wrong sign up here. Yeah, that's why it was wrong. No, not well, because you magically changed things, but your work along the way was wrong. That doesn't count. Yes. Good. No, because they follow your work, and if your work doesn't jive and you make stuff up along the way, you absolutely do not get credit. Well, then maybe you get lucky, but I wouldn't count on it. Yes, you have to find the second one. Not on the outside, because you're taking the derivative of the derivative. After you, the next step is the next step. Yes, that's why I want you to write that out there so it makes sense. And when you get to this step, if you put dy dx equals this, that's fine. It doesn't matter either way as far as the equal. I just wrote what I had down there. Same kind of mistake on there. Very good. Told you. Okay, so that's right. So that gives you the numerator, right? So you put parentheses around it, there's more than one term. So the derivative of the first one times the second one. So you multiply that by that. Well, just 1 plus x, not the derivative. Yeah, just what it is, not the derivative. No, 1 plus x, not the derivative. Yeah. Then minus and then go for that. Okay, everything except that, since this is more than one term, you need parentheses around that. You're going to end up with a grouping error. What are you doing? Yeah. Say it to yourself every time. The derivative of the first times the second minus the first times the derivative of the second over the denominator squared. Or you can say top and bottom, but if you say first and second, it works for product and quotient. So I have one thing left to do here, right? I have to do 2 minus my dy dx, which is 2x minus y over 1 plus x. Parentheses here, super important. And then times 1 plus x minus 2x plus y. No, it doesn't. All over 1 plus x squared. Now, here you have two options. You can distribute it, or you don't have to. You can leave it minus and make this a negative y as long as you have your parentheses there. So you just have to decide either I'm going to leave it, which may be safer, or are you going to distribute? Whichever one is fine. Okay, and this equals d2y over dx squared. So the good news is you're not going to have to do this a ton, but you do have to know how to do it. Okay, and if you can take the derivative, you can take the second derivative, but depending on the function, the more derivatives you take, the funkier it'll look. Some of them, the easier they get, but some of them, the crazier they get. Okay, what questions you got? We good? Okay, good deal.